Well, now that we understand the empirical formula, it's time to get into the molecular formula. And the first thing here is the molecular formula consists of chemical symbols for the constituent elements followed by numerical subscripts describing the number of atoms of each element present in a molecule. The empirical formula represents a simple whole integer ratio of the atoms in that compound. So in order for us to get the molecular formula, right, the first thing you need to do is you need to find the empirical formula. Right, once you have the empirical formula, you need to find the molar mass of the empirical formula. So I'm just using EF here, so I don't have to write it each time. You can do the same. All right, once you've got that, and you need to find the ratio of the empirical formula to the molecular formula molar mass, in terms of molar mass. Okay, once you've got that, you need to multiply the subscripts of the empirical formula by the ratio. Okay, so this is how we're going to sort this out. You cannot get the molecular formula without getting the empirical formula. So this is how to find the molecular formula. Okay, now in order to find the molecular formula, there's something that you must have. This is very NB. In order to find the molecular formula, you must be given the molar mass of the sample. Not the mass, the molar mass. Remember, molar mass is in grams per mole. That must be given to you. You will not be able to find the molecular formula without the molar mass. Because if I look at step 3 here, I need to find a ratio. In order to find a ratio, I need two numbers. It's easy to find the empirical formula because we're going to be given percentages or grams. We need the molar mass of the sample that we're working with. If you don't get the molar mass, you will not be able to work out the molecular formula. All right, so what you need to understand about this section, you will be given the percentage composition, okay, or you will be given in grams the sample size, okay. You will need to find the empirical formula first. You will need to find the molar mass of the empirical formula. You will then need to find the ratio of empirical formula, of the molar mass of the empirical formula to the molar mass of the molecular formula. You will then need to multiply subscripts by ratios, and that will give you the molecular formula. We're going to use the same method we use for the empirical formula to keep our working out in order, and then we're going to do a second step. So at this point, you know how to work out that, but this is what we haven't done already. All right, so let's just have a look at the first example. Here's our steps. We need to find the empirical formula. then the molar mass of the empirical formula, then the ratio, then multiply the subscripts. Get my steps. I've got the empirical formula. I need the molar mass of the steps are in your books. You need the ratio of the empirical formula to the molecular formula. Go back to my steps. Multiply the subscripts of the empirical formula by the ratio. Right. Example 1. Vinegar, which is used in our homes, is a dilute form of acetic acid. So that's your next acid that we work with. A sample of acetic acid has the following percentage composition. Guys, when I say vinegar is acetic acid, that means I've told you now. You need to make sure you remember it. You need to know what nitric acid is, hydrochloric acid, stomach acid, battery acid. You need to see those links now. Has a composition of 39.9% carbon, 6.7% hydrogen, and 53.4% oxygen. They want the empirical formula of acetic acid, and then what they want is a second question: determine the molecular formula of acetic acid if the molar mass of acetic acid is that. So remember, I said to you, you cannot work out molecular mass if you don't have the moles, the molar mass of that sample. All right, so they've given you all of this. The first thing we need to do is find the empirical formula. So remember, so let's go. That means if you get the empirical formula marked as incorrect, then you will not get any marks for the molecular formula. There's a chain reaction. Because there's no calculations here, there's no continued accuracy, you need to be accurate. All right, so we put it in the order that was given to us: carbon, hydrogen, oxygen. And this time they have given us percentage. Just get my pen sorted out. They've given you the percentages. And we're going to have to convert to mass. Now we can only convert to mass. Now they haven't given us the size of a sample, so we know we need it to be at 100%. Alright, so they've given you 39.9, 6.7, and 53.4. When I add that up, I get 100%. And if I get 100%, then I can sort out my masses at 39.9, 6.7 grams, and 53.4 grams. All right, the next thing I want to do is I want to find my moles. I do the same thing over and over again. Just get into good habits, otherwise you make a mistake, it costs you. All right, so the first one is carbon. So 39.9 divided by 12, 6.7 divided by 1, and 53.4 divided by 16. All right, pause the video. See if you can continue with the rest of this. And then you can see your answer afterwards. All right, once you've sorted that out, you have to identify your simplest ratio. And look at the decimals. It's both 3.3, but we're going to use the smallest ratio. So we've got 3.325 divided by 3.325, 6.7 divided by 3.325, and 3.3375 divided by 3.325. And the whole number ratio you should have gotten was 1 to 1. Alright, so now we've got our empirical formula. So therefore the empirical formula is CH2O. Alright, so that answers question 1. Determine the empirical formula of acetic acid. Question 1, done. Number 2, question 2. They want the molecular formula. Alright, so question 2. They want the molecular formula if the molar mass of acetic acid is 60.06 grams per mole. Okay, all right. Once I've got that, I want to write down my empirical formula, which is CH2O. Okay, so if I look at the formula, so I go molar mass of CH2O is 12 plus 2 times 1 plus 16, little bit of mental math, And that gives me 30 grams per mole. Okay, so I've got this. Here's step 1. I've got the empirical formula. Step 2, I needed to find the molar mass of my empirical formula. Done. Right, step 3. So we go to step 3. Please make sure. So the formula we use is ratio is equal to the molar mass of the molecular formula divided by the molar mass of the empirical formula. Okay, so I just do a simple one. R is equal to mmf over MEF. You can just write that down. Alright, so my molar mass was 60.02 of my acetic acid, and my empirical formula's molar mass was 30. Alright, if I put that into my calculator, I should get the ratio at 2.02, which I can then round off to 2. So here is my ratio. Okay, once I've got my ratio, alright, so if I go here, step 4, my empirical formula we found at CH2O. All the subscripts must be multiplied by 2, which is my ratio. Alright, so let's have a look here. So it's going to read, therefore, the molecular formula is C2H4O2 of acetic acid. There we go. That is your answer. And if I had to write out acetic acid, right, in its true formula, if I had to draw it out, it would be CH3COOH. That is the formula for acetic acid. Not something that you need to know. You only needed to find the molecular formula. This is its true chemical formula. The true chemical formula. So vinegar in your house has acetic acid in it. That's why it's got such a sour taste. This is the molecular formula. So again, you have to first find the empirical formula. Done. Find the molar mass of the empirical formula. Done. Find the ratio by dividing the molar mass of the molecular formula by the molar mass of the empirical formula. Done. Then multiply the subscripts by that ratio. Done. And then write down a final statement of what the new molecular formula is. Don't forget, the subscripts are the smaller numbers. But you know this because you did this in grade 10. And let me do another example with you. A second kind of example that they can give you is they can say to determine the molecular formula of a compound with an empirical formula of CH and a molar mass of whatever they give you, right? So they've already done the empirical formula work for you. So the first thing, you've got your empirical formula, that's CH. The second step is the molar mass of CH. Alright, so nice and basic, 12 plus 1, and that gives me 13 grams per mole. Alright, the second thing I need to do is I need to find that ratio. So R is equal to MF over oops, what am I doing? EF. Alright, so the molar mass here is 78.110 divided by 13. Alright, so the ratio is 6.008, so I'm just going to make the ratio is equal to 6. And therefore, number 4, I'm going to take CH times everything by 6. And therefore, my molecular formula is C6H6. Oops. C6H6. There's your answer. So that was nice and basic. Let's get another one. Right, the percentage composition of an unknown substance is 75%, 75.42% carbon, 6.63% hydrogen and 8.38% nitrogen and 9.57% oxygen. If its molar mass is 334 grams per mole, what is the empirical and molecular formula? Right, so now we've got a substance with 4 atoms. So our table needs to expand. Please make sure you draw an expanded one because you've got carbon, hydrogen, nitrogen, and you've got oxygen. Right, so you would have had set up your table by now, and please try and do the whole table without my help. Double check if everything equals to 100 as well. Right, so I've got 100% there. I can convert directly to grams, 75.42, 6.63, 8.38, 9.57. Alright, so I just have to work out all my moles. So I've got 75.42 divided by 12, 6.63 divided by 1, 8.38 divided by 14, and 9.57 divided by 16. Right, all you got to do is pop that into your calculator. Try and hold on to those decimals because you need to determine your simplest ratio. Right, at this point, this is what you should have with you. And I can see my problem already is here. Alright, so what I want to do there is I want to get that 10 to be its next whole number. So if I say 10.5 times 2, I'm going to get 21. And that is a whole number. Alright, so I'm going to multiply everything here by 2, giving me 21, 22, 2, 2. And that's my simplest ratio. Alright, so I'll go C21, H22 into O2. So therefore, my empirical formula is that. Right. Now what I need to check is my molecular formula. Okay. So remember with the molecular formula, we start with the empirical formula, and you've got C21, H22, N2O2. Okay. That's one. Number 2, we want the molar mass of this. So molar mass of C21, H22, N2O2 is, I'm just going to do it here, 21 times 12 plus 22 times 1 plus 2 times 14 plus 2 times 16. Okay. Pop that into your calculator, and that should give me 334 grams per mole. Alright, step 3. What we need to find now is the ratio. Molar mass, molecular formula divided by molar mass of the empirical formula. And the molar mass of the molecular formula was 334 grams per mole. Hope you're seeing that now. You would have 334 over 334 giving you a ratio of 1. So that means, therefore, the molecular formula is C21, H22, N2O2. What I want you to notice here is this is possible. Right? Especially with these. This is an organic compound, which is a section you'll do at the end of this year. So sometimes this does happen, where your empirical formula and your molecular formula is exactly the same. Right? So that's your last example. I'm going to go into waters of crystallization, and then we're going to start looking at a little bit more intense work. All right, waters of crystallization. Now, what we now add in is a little bit of a degree of difficulty to understanding what's happening here in terms of chemistry. When I have crystals and I put them into water, and then I try and get that crystal back, it's already been exposed to water. I can't get all of that crystal back to its pure form. So what we call that is, after I've taken a salt, okay, so I'm just going to make a note here. There's two types. There's hydrated salt and anhydrous salt. A hydrated salt is a salt that has been previously dissolved in water. And then after it was dissolved in water, it went through the evaporation process. So what's actually happening, it is slightly hydrated, right? It is slightly hydrated. That means it has a bit of H2O attached to it. An anhydrous salt, however, has not been exposed to water in any form. So look at the colors, right? Both are copper sulfate, copper 2 sulfate. The one is copper 2 sulfate pentahydrate, and the other one is just copper 2 sulfate. You can see the difference in the type of crystals you have. With the copper, the hydrated salt is blue in color and it's got a rough consistency, and the anhydrous salt, copper 2 sulfate, is white and it's got a powdery kind of consistency. Right, we are going to do calculations based on what happens when I do have a hydrated salt. What we call that is waters of crystallization. Water of crystallization is water that is chemically bonded into a crystal structure. Here's the formula of hydrated copper 2 sulfate up here. Okay. Notice that the water of crystallization is separated from the main formula by a dot, and we can see that dot over there. Hydrated means that the solid crystals contain water of crystallization. It means during the crystallization process, it retains some of the water that was involved in that kind of in that reaction. So we're going to look at how to do the calculations we've been doing now and look at waters of crystallization. All right, this is an example of how this would come across in an exam. This is a past paper question. You need to make sure you pause the video, take down the question, so that when I start explaining it, you're in a better position and you're not still writing down the question. It says aluminium trichloride is an ionic substance that forms crystals in the solid phase. Water molecules may be trapped inside the crystal lattice. We represent this as AlCl3 dot XH2O. Karen heated some aluminium trichloride crystals until all the water had evaporated and found that the mass after heating was 2.8 grams. The mass before heating was 5.08 grams. What is the number of moles of water molecules in the aluminium trichloride before heating? Right, there are steps to doing these calculations. I'm going to go through each step with you. All right, step 1. The first thing we need to do is we need to find the number of water molecules. Okay. All right, so in order to find the number of water molecules, we need to find N, the number of moles. Right, so we're looking for N. Okay, so right now we've got AlCl3 dot XH2O. We need to find that X. And remember what I said, coefficients are moles. Right, but we don't have everything in moles. We have everything in mass. So we need to first sort that out. So that's what we need to find. All right, so what we're going to do here is we need to find the mass of water loss. Okay. Now, if I look at it, they said before heating, it was 5.08 grams. And after all the water had evaporated, you were left with. So this was the before amount. And then after evaporation, you were left with 2.8 grams. Okay. And so now we need to find the mass of the water loss. So therefore, 5.08 minus 2.8, and that should give you 2.28 grams. All right, and that is your water loss in this whole evaporation process. All right, step 2. You need to find the mass ratio. Okay, so you've got two things here. We now know that that's your water loss. So this here was, make a note for yourself, water plus AlCl3. This here was AlCl3 with no water. Okay, so now we have to look at the two ratios, right? So I've got AlCl3 is to H2O, and the ratio is 2.8 is to 2.28. Okay, and it's in grams. Now the problem with this is we can't just somehow just work with grams. We need to find out your moles, or whatever your situation is, your moles, right? It is not possible to work with ratios in grams. It is not possible. All right, so what we can do is we can go from grams to moles. It's a conversion. Okay, it's a very important conversion. If I have grams of two things, I cannot do ratios. I have to get those ratios into moles. Now I know my formula is N is equal to little m over big M, right? And what I can do now is I can work with each one. I can say AlCl3, and I work with it together. So kind of like the table situation, so I keep all my calculations together. I've got my formula, so I've got the mark. Now my AlCl3, my mass that I'm given is 2.8 divided by the molar mass of AlCl3. So if I want to do that separately, I can say 27 plus 35.5 times 3. And that's my molar mass of AlCl3. My molar mass of water would be 18, what am I doing? 2 plus 16. And that's going to give me 18 grams per mole. And I've got here 133.50 grams per mole. Okay, so 2.8 divided by 133.50 and 2.28 divided by 18. All right, so over here, I'm using my moles formula to get the 2 moles. All right, once I've got that, I can put it into my calculator. Oops. And I want to hold on to the decimals because I think you guys know what needs to happen next. Okay, once I've got that, I've got my mole ratio. So I've got my moles for each, right? So to find this, I'm making notes here. To work out the mole ratio, we use the formula N is equal to M over M. Okay, maybe I should make that M a bit better. Okay, That's what we did there. Right? The next thing you need to do, right? We need to get a whole number ratio. Okay. So what we're doing here is step 3. Okay. There's step 2, and now we're busy with step 3. Now to find the whole number ratio, you've done this before. We must divide by the smallest ratio. Okay. So I must divide both sides by the smallest ratio. So if I look here at my smallest ratio, it's the aluminium one. So I'm going to go 0.209737877 divided by 0.20973787277. Okay. Then I'm going to take 0.126666667 divided by 0.02973 and so on. Alright, from there, put that into your calculator. You're going to get 1:6. Alright, that means, alright, this gives me information. Therefore, the ratio of AlCl3 to water is 1:6. Okay, so we know the formula at the moment is AlCl3 dot XH2O. Now I've got here 1 mole of AlCl3. And if I've got 1 mole of AlCl3, I need to have, if I have 1 mole of AlCl3, I must have 6 moles of H2O. Okay, so what we've done by working out this ratio is if we found the coefficients. So don't forget, this ratio here is the coefficients. Now I can see that this 1 corresponds there, which means this 6 must correspond to the water. So therefore, the formula is AlCl3 dot 6 H2O. And that is how you do waters of crystallization. Right? It's the same thing. We can perform experiments to determine the composition of substances. For example, blue copper sulfate, CuSO4, crystals contain water. On heating, the water will evaporate and the blue crystals become white. So by weighing at the start and end of the products, we can determine the amount of water that is in copper sulfate. Right? Even you can go from copper oxide to copper. So this is how you do water of crystallization. So I'm just going to go through it here. This is step 4. That's your final answer. All right. So the one thing you want to start with here is you want to look for the water loss. So you look at before the experiment started, that's what you had, after what you had. So if the process is evaporation, there's going to be a loss of water. That's what gets lost. So when you do the minus sum, it's the full experiment minus how much was left over, whatever salt was left over. And whatever answer you get is always going to be that loss of water. Once you find the mass, the second step is to find the mass ratio. Remember, you cannot work with ratios and grams. Those grams need to be converted into moles. How do we do that? We use our formula for moles. Can you see I've got moles and I've got mass? So I can use that formula to go from mass to moles or moles to mass. Once I find that, all right, Remember, this calculation corresponds with that formula. So you get a mark there, marks for substitution. Once you get the ratio, you need to go in, find the whole number ratio. How do you do that? You find the smallest ratio. Once you've got the smallest ratio, you divide both sides and you get an actual whole number ratio. Once you've got a whole number ratio, that whole number ratio is the coefficients. Then you need to check your formula. For every AlCl3, you need 6 moles, whatever your moles are. And the last step is write down your final answer. So please make sure you follow those steps. All right, and remember, I just told you guys about the copper sulfate, how the process works. You weigh by starting and the ending products. This little note that I've attached here, please make sure you write that out in your books. All right, this is video number 3 at its end. We'll move on to video number 4. So what you've done now are all the notes pertaining to grade 10 quantitative chemistry. The next set of videos that I'm going to upload is two or three more videos is on the grade 11 notes. And when you come back to school, we're going to start with the big calculations for this section. We will give you introductory activities to do. I'll see by the time I get to the last video if I'll upload some worksheets with memos. But right now, it's all about taking the notes and making sure you have everything in your books. So these are the first 3 videos which have been uploaded. There are other videos that are going to follow these 3. Please make sure you check video number 4, 5, and there will be a video number 6.